Chapter 1. The Spiral Force. The point of describing the torus in such a way is so that it can be used as a model for force in nature. As quantum physics and plasma cosmology are now plainly showing, electromagnetic waves are at the root of all phenomena. Therefore, this chapter will show how electromagnetic waves follow this ideal field model so that it can be used to model any function of nature. Image number 1 is the basic accepted idea of a magnet. The basic force around such a magnet is shown in images 6 and 7. If a small slice of that magnet is taken, image number 2, the slice instantly polarizes and possesses the same qualities as the parent, although on a smaller scale, image 3. This is called recursion. The slice has a meridian that is perpendicular to its axis, aligned as its parent. The axis is defined by a ray attaching the two extreme poles. If two such slices are put together, axis to axis, an imitation of the parent magnet is recreated, image 4. However, when the magnets are combined side by side, image 5, they attach, but the final field is much different from the circular field of image 6 and 7, see image 14. It is in this arrangement where the relation to the torus becomes clearer. To understand it better, the idea of north and south are better thought of as vectors, directions of motion, as opposed to charge. Image 6 shows the vectors commonly thought of, and image 7 is showing the same vectors in classic iron filings. The vectors above depict a motion similar to two gears meshing together, image 8. Yet, all of these images are merely two-dimensional. To draw a complete parallel to the three-dimensional ideal field model, vectors need to be plotted for the sides of the magnet as well, image 9. When vectors are plotted for the sides, the spiral vortex is clearly revealed and their interacting behavior becomes predictable. Image 11 shows a spiral sphere as a stylized representation of the final vector field that is generated after plotting the vectors in 3 dimensions. This is the ideal form of the torus model. Understand that a sphere with an axis is a torus because the axis is a hole, however small. Note, image 11 is not an exact model, such as the specific angles of the vectors. It is being considered here for sake of simplicity in modeling. Image 11 and 12 detail the 3D vectors of the two-axis scenarios, axis to axis and axis by axis, respectively. Now the interaction that occurs when vortices are side by side can be better understood, and one can see why the final fields of the two are so different. See image 14 again. While image 4 aligns to form one single axis, image 5 has two axes. A phantom axis then attempts to form perpendicular to these two existing axes, image 10, due to their interacting flux, clearly shown as the hole in the middle of the image, 14. It is proposed that matter itself prevents these two axes from merging into one ideal axis, explained later in detail. Otherwise, they would become the meridian of the new ideal field and fully manifest a new single axis perpendicular to the old ones, image 12, forming the ideal torus, image 11. The interior axis is a thin vortex traveling as a ray which defines a spiral wave, while the exterior is a bloated vortex occupying a specific space acting as a particle or field. Yet they are both merely one cycle, inseparable from each other, just as is the magnetic field around the electron in a wire. Image 11 and 12 may thus be considered as a model for any individual point, particle, or ray, wave, of any field, or the entire system of any field, because it is a recursive model, happening exactly the same throughout the entire field, albeit in different scales, just as the divided magnet becomes a smaller aspect of itself. Notes: 1. Image 12 may be referred to when imbalances in systems keep them from fully unifying. 2. Spin is relative to the perceiver. Looking at image 11 from the north side, all things seem to spin clockwise. However, if the observer perceives the same model from the south, the entire system appears to be spinning counterclockwise. These images are two views of the same configuration, two magnets lined up axis by axis as opposed to axis to axis. A wavy torus is revealed. Notice how images 13 and 14 are similar to the p and d orbitals in image 15. Further note that the s orbital can be created by lining magnets up axis to axis, thus easily creating the ideal field, image 11. The closer the physical geometry of the combined magnets is to a sphere, the more true to the ideal field model the final field will behave. It is proposed that the true path of all field lines are spiral in nature, and that the axis is also a vortex, neither of which is easily viewable with the classic methods used in images 6 and 7. With two-dimensional iron filings and a two-dimensional compass, one can only plot a two-dimensional vector. This is why the spiral is not noticed in such limited past analysis of magnetic fields. Thus, to observe magnetic field lines in 3 dimensions, it is accomplished well by employing ferrofluid, as in image 13 and 14. Ferrofluid is basically iron powder suspended in light oil, which easily conforms to the magnetic field in 3 dimensions with notable detail. When working with ferrofluid, at first it is observed that uniform geometries of a base magnet or uniform charges simply make a grid-like field, nearly identical with the classic field line interpretation, image 7, and seemingly there is no spiral. However, a spiral can be revealed in 2 ways. 1. By increasing the amount of ferrofluid on a non-spiraling base form of A. Uniform geometry, and B. Constant charge. The variable is the amount of fluid, matter, which consequently increases the distance of the ferrofluid's surface from the center of the magnetic flux. See image 16. At first, the ferrofluid seems to assemble in a uniform grid. As the amount of fluid begins to increase and the quote-unquote spiked tips of the ferrofluid get increasingly further from the center of the charge, the tips of those points will travel in a spiral. Therefore, a spiral is traversed by a point from the center of the charge to its perimeter. This explains why a static model cannot observe a spiral, because it is only measuring one radius from the center, namely the final surface. To illustrate, imagine measuring just one point on the last outer sphere of image 16, instead of considering all 5. It could very well be concluded that the spiral is a 4th dimension of quote-unquote growth or motion/time. 2. Simply creating a spiraling base form, image 17, with constant charge, and then adding ferrofluid will cause the fluid to move in a spiral. This is unlike the other form where the fluid merely assembles thereon without visible movement. The variable is again ferrofluid amount. This type of base form allows the fluid to seek its equilibrium on the x, y, and z axis, unlike the other forms. Note that even though ferrofluid always forms 3-dimensional models, if the faces of the base form have only 2 planes of movement, the dynamics of the force are not properly modeled because it is limited by the 2D planes of the base model. In forms where each face is a 2D plane, the third spiral z-axis is created by the fluid itself. Thus, the spiral motion is occurring within the fluid, below the surface, and cannot be observed except by the first method. This motion is captured clearly by the spiral base model. The following web video is an example of this. See the link on the screen. Note: for sake of simplicity, image 16 only roughly plotted this spiral on the x and z axis. However, it would also have deviated along the y-axis as well. Image 18 depicts the initial doubling diagram, page 3, described in a DNA spiral. In green is the field between the pairs. The spiral can further be revealed by the ideal field model itself, page 4. Simply by following the patterns of numbers below or above the model's surface will show that the pattern is 3-dimensional. Not only does it show the spiral, but it also reveals the nature of each number in more detail. For example, cube A is the cube of the numbers around positive 8. Notice the positive 8 is directly in the center of the cube. Next to image A is the cube of negative 4. Note that negative 4 is always next to positive 8 in the number pattern, image 0. Now it can be seen how these two numbers interact in more detail. Observe the balance that is maintained. This reveals even more insight to the signatures of each number. It is proposed that the study of this pattern will lead to thorough knowledge of the numbers as being 9 aspects of one force of manifestation. Once each aspect is fully understood and how it reacts with the others, patterns will then be able to be skillfully assembled with energy itself, resulting in truly man-made materials. From strings to atoms to molecules, man will have a new level of manufacturing. The twisted structure of complex proteins will become clear. Massive fields around galaxies will be harnessed. The universe will become a sandbox to man's creativity. All that any unit of matter is a symphony of vortices, an orchestra of these aspects. A field or particle always attempts to get as close as possible to the ideal model, governed by the most perfect geometry throughout all scales of size, from 1. The specific geometry of the subatomic particles composing the atoms of the material used, electrons, protons, etc. 2. The geometry of the alignment of those atoms making up the material. 3. The geometry of the pieces of said material employed. And 4. The geometry of the array of those shapes. Therefore, by careful choice of material, microgeometry, and its geometry when assembled, macrogeometry, any field can be manipulated and directed. The most perfect and symmetrical geometries allow force to travel unobstructed. Any impurity taints the force, resulting in an imperfect field directly related to that impurity. This then directly causes the quote-unquote characteristics of that particle or field. Thus, carefully crafted imbalances can direct force. For when force is perfectly balanced, it interacts with everything equally and thus appears to be unreactive because of such uniformity. Precise imbalances and perfect imperfections are key. This force is the so-called zero-point energy, wisps of which can be seen in permanent magnets due to their small degree of symmetrical internal geometry, the alignment of electrons. It is this force which this paper shall model. To conclude this chapter on the relationship of the electromagnetic field to a spiral, and that spiral being related to a system of numbers, here is a small note on how the humble number system may be even more profound than what was previously thought. Notice in the image below that the 4 and 7 are mirror images rotated 90 degrees. The 2 and 5 are mirror images rotated 180 degrees. And the 3, 6, and 9 are direct depictions of a vortex. The 3, shown in gray on the right, is a 6 or 9 with the face removed on a line tangent to the inner circle and its own tail. Notice how they also hold mirror positions on the page 2 diagram. As for the 1 and the 8 is the infinite curve, the Mobius strip, and the 1 is the infinitely straight, the ray, both exact opposites of each other. The above images suggest that a toroidal galaxy is a calculable system based upon recursive mathematics. The simple Julia set fractal on the left is an exact recursive formula, and also ideal. Just as with the ideal gas law, no gas behaves ideally. Nature is far more complex. The law simply helps humankind work with and understand such complexity. The same is true for the ideal field model. Gas, plasma, and fluid mechanics all propagate in complex recursive iterations, which are all more clearly grasped with the ideal field model.